All right, so this one here is a very similar one using a SecML to poison. The only thing is there's some visualization of the process here that might help understand it. So let me make a new move to trash, make a new Colab book here. All right. And we're doing 110, which is here. Okay. So, as usual, we already have SecML. I've already imported. Oh, I made a new network. I probably do have to re-import SecML. Perhaps I shouldn't be starting a new notebook every time for these. Anyway, now we're going to make a data set, again with the 3 groups of points in a plane. All right. It's going to look like that. Oh, 2 groups of points in a plane this time. All right. And now we train a model, again using the default model, which I think is a support vector machine, just a classifier. All right. So we are going to separate the red dots from the blue dots. And here's a machine learning model doing that, called CLF, and getting 94% accuracy. This is all the sort of thing we've done before. And so if you want to see the decision boundary, that is here. All right. So it's got blue and red, and it's chosen this curve as the boundary, and that gives it 94% accuracy. Now, we can perform a poisoning attack and visualize it. And again, we're using an advanced poisoning library that takes the complete classifier and feeds it in, so it's able to carefully design a malicious attack. And what it's going to do, let's see how this looks. Right, it's going to take 1 poisoning point to generate, and it's going to do that by moving one of the existing points. And what you have here, so before poisoning, it was at 0.57, 0.87, and after poisoning, it's here. So here's where it started at the star, and it's going to move that dot up to the gradient. And the point is, it's moving to a region of greater importance for the model. This is the objective function, which I think is the, I'm not sure, I think this is the cost function or something quite similar, showing the color here, shows the cost function, and it moves it out of some region of, I think, low slope to a place where there's a strong gradient. So this helps you see it. It finds what areas in the parameter space are most important to the model. And this area, where the color is changing rapidly, is where it's a sensitive point. Bad data in this location will injure the model more than bad data out here on a flat area. So that's what it's doing. It calculates how to move this point in such a way as to do the most damage to the model. And so you can then see the performance of the poison model after poisoning just 1 point. And so that lowered it by 1% by moving just 1 point, from 94% correct down to 93%. And here you can display the data before and after the poisoning. And you can see, here's the original classifier, and after it's poisoned, you can see it's distorted this quite a lot. It's caused this point up here has caused it to completely distort the decision boundary to try to include this blue point in this. So you can see how if you're going to poison it with just one point, that point has a really big effect on it. And this is for the training set. And if you use the test set, then you'll see how the shapes are determined by training. Now you put in points it's never seen before to classify, and you can see why the accuracy falls. This is now going to misinterpret this red dot as blue. That's the one dot that's misinterpreted in this test that caused the accuracy to drop. But anyway, that just helps, I think, understand how these intelligent poisoning attacks work. As opposed to just throwing random noise on the image, you find the hot spots where a little bit of noise here will really confuse the model a lot. And there's some flags to find by doing variations on this. So that's the poisoning, showing you the gradients underneath it so you can see how it works.